Hello everyone for the second time today. So I'm going to talk about confidential GenAI as a service, how we build the Privatemode service. And the first question I want to briefly discuss is, what is confidential GenAI? And I think it's pretty self-explanatory. You have an AI, you have someone sending prompts to that AI, and there may be threats that this person is worried about and is thus reluctant to share data. So this may be, again, hackers in the infrastructure. It may be nosy employees of the AI provider, etc. So the simple solution, of course, since we are at the Open Confidential Computing Conference, is to put everything into a confidential computing box. Simple as that. Well, turns out it's not that simple in practice, at least if you want to have something that's actually secure and that's scalable and that's providing good performance to the end user. Because let's face it, people are only going to use security if it's not getting into their way, right? If it's super complicated to use a confidential AI, everyone is just going to continue using ChatGPT for everything, and is maybe just redacting names in some legal documents, etc. So we really need to also nail the UX, which includes performance, etc. And I think we're getting there with Privatemode. Privatemode is, as I will discuss in more detail, an online service for AI inference. You can find that at privatemode.ai. And it is a service that is aimed at institutions that have sensitive data. But not only that, also individuals. So it can be used for free in a free trial. It can be used with a credit card. It's not very expensive. But the primary target audience is public sector institutions and enterprises. And if you attended the pre-event today, you will have heard about a great use case, great project in our home state of North Rhine-Westphalia. There, Privatemode is being rolled out to the public administration, and soon many employees in the public administration will be able to process sensitive data with LLMs based on Privatemode. So the rest of this talk is about the design goals of Privatemode and the architecture, how we build it. So quickly, some design goals. And first design goal is very simple. We wanted to have a cloud-based service similar to what OpenAI is offering in limited quality, or not all the features all the time, but something that is very good for many use cases. And it should have an app and an API that people can use it with. Second, pretty simple, end-to-end encryption, of course. Third is end-to-end meaningful attestation. So you will have heard already today a lot about attestation. Attestation is the second important pillar of confidential computing. Without attestation, confidential computing does not work. And therefore, it's very important to have that. And a critical goal is to make attestation meaningful so that the user can actually establish trust into a service based on the remote attestation. And lastly, we wanted to have what we call black box properties. So using confidential computing to protect a service against the infrastructure is one thing. The other thing is using confidential computing to also exclude the actual service provider from a service. So we did not only want to exclude, let's say, Microsoft Azure or another cloud that we run on, we also wanted to exclude ourselves so that we can give the assurance to our users that even our own employees can never see the data in plain text. Okay, with that background information, let's take a look at this again, and let's zoom into the architecture of Privatemode. This box, on first glance, may be more complicated than you have thought. So we have here we have a couple of things we need to unpack. First of all, whoops, sorry. No, it's fine. First of all, bottom left corner, we have Kubernetes, so everything runs scalable on Kubernetes. Then we have three gray boxes. We have the secret service, we have the contrast coordinator, and we have the worker nodes. The worker nodes are the most important part here. They are confidential containers that include AI code that runs our LLM and talks to the NVIDIA GPU. And next to that, we have the contrast coordinator. This is the component that coordinates everything within the cluster. My colleague Moritz gave a talk on contrast earlier today. And then we have the secret service, who is just managing secrets. That is the basic architecture. All of these three components run inside confidential containers, and all of them are managed using contrast. I have the problem that I cannot advance the slides anymore. There it is. Okay, that was a temporary problem. So inside the AI code, we have two things that are important. First one is the VLLM framework. That's an open source framework for serving LLMs for inference purposes. So this is offering an API to the outside, and you can call that and send your prompts there. Part of the AI code is also the Llama 3.3 open source model that we use. And that are the most important parts of the AI code. Now let's take a look at end-to-end remote attestation. That was the first thing, or one of the design goals that I mentioned. And here's how it works. So we start with a manifest. If you attended Moritz's talk, you will have seen that the manifest is an essential part of contrast that is generated automatically of the Kubernetes YAML files that describe a containerized service. So this manifest, well, it is human readable. Not very much, but it is human readable, and it essentially contains a bunch of cryptographic hashes that correspond to the containers and the rules that are allowed to run in the cluster and that fully describe the behavior of the service. So this manifest, I don't expect you to understand this or to read this, contains, among others, hashes that correspond to the three services that we have running inside this cluster. So this manifest initially goes to the contrast coordinator, which is running inside a confidential container, inside a confidential VM. Now the contrast coordinator uses this to verify the other components using remote attestation. So it first verifies the secret service, verifies that it's running precisely the expected code, etc. Then it verifies the AI worker. And the AI worker, specifically the attestation agent running inside the AI worker, verifies the integrity of the NVIDIA GPU, also using remote attestation. And then, last step, the contrast coordinator sends one single attestation statement back to the user. And this essentially says, hi, I am contrast coordinator version 1.1. I verified that this cluster corresponds to the given manifest. And by the way, I am also running inside a confidential container, and therefore you can trust me. So it's one statement that describes the entire cluster. And we don't expect people to examine that attestation statement themselves, but we give them an app. So the only way you can use private mode is via an app. And the reason for that is it's very difficult to securely check attestation statements within browsers. Right? So we provide an app that's a native app for Windows or for Mac. iOS is coming. That is verifying the attestation statement when you open up the app. And then it will display a green check mark bottom left, but it will do the verification for you. The other thing is a proxy. And if you want to use the API, you have to use our proxy or the upcoming SDK. And that proxy is doing the same thing. That proxy is automatically verifying the integrity of the cluster. So that gives us end-to-end remote attestation. Now, an expert user could go and now check GitHub, because all of the code is uploaded to GitHub, and all of the artifacts can be reproducibly built. So if you wanted, you could inspect the manifest, look at the hashes, go to GitHub and build precisely the same software yourself, and then you would end up with the same hashes. That's how an expert can verify that the backend is indeed a good backend. So end-to-end encryption, that's pretty simple. So we have runtime encryption through the CVMs, and initially, after remote attestation, the user exchanges securely a key with the secret service. And the secret service then passes the secret on to the AI workers. After that, the user, using the app or the proxy, can just send prompts to the AI code. And this happens via an OpenAI compatible API. So you can use this as a drop-in replacement for your existing OpenAI-based deployment. Okay, so last thing we wanted was the black box properties, if you remember the design goals from the beginning. And I don't really have time to go into much detail here, but we have end-to-end attestation, we have end-to-end encryption, we have reproducible builds, and everything is designed so that no outside access from admins, etc., is possible. Bottom line is, no one can see your prompts, even not Edgeless Systems employees. Now, scalability, I mentioned that as well. The system is designed to be horizontally scalable. So we can easily spin up new instances without compromising security or having to do remote attestation again from a user perspective. This currently runs on Scaleway in France. We have a cluster of NVIDIA H100 equipped machines there. The reason why we run there is, A, we wanted to have a European cloud, and B, Scaleway is giving us raw access to the machines, so we can make sure that precisely the right firmware, etc., is running inside the CVMs. So benchmarks. I talked about scalability, performance, it's an important thing. Here is a brief benchmark of Privatemode against GPT-4o and Hugging Face serving Llama 3.3. Privatemode is the purple line. I mean, we have some room for improvement with regard to ChatGPT when it comes to total response time, but I would argue that total response time for a long query of below 20 seconds is already pretty practical for many use cases. And we're working to improve that. Here's a feature roadmap. We already implemented streaming. We implemented tool calling so that the AI can itself call other tools again. We will implement prefix caching that will vastly improve performance. We will implement multi-GPU support with B100, also something that will impact performance and also model variety. We can have larger models. And yeah, we will add support for more models. For example, DeepSeek, possibly in the future. And that's the most requested feature, native file upload and RAG. I mean, AI is useful, but it's even more useful if you can have it work on your own organization files. So, if this sounded interesting to you, I invite everyone to try out Privatemode. Go to privatemode.ai, and you can just get the free trial with the email address. You don't need to put in the credit card. Just sign up, and you should be ready to go within like 5 minutes. And then you can use the app, or you can use it programmatically, for example, from a Python file. That's all I have for today. I'm very proud of the achievement all the achievements that the team managed on the technical side. And yeah, looking forward to further discussions and questions. Thank you.